All right, so today we're going to talk about the probability of simple events and what that means. So first, I want us to get a spectrum of what probability is. Okay, what is probability, and how it works, and as far as percentages, we're talking about percentages and fractions. So first thing I want to do is kind of get a spectrum here. On one end of the spectrum is something that's 0% chance, 0 out of 1, impossible, not going to happen. Right? So if it's impossible, so for example, if I was to go out to the basketball court right now and I had a basketball and I said, I'm going to dunk this ball, I'm going to jump up and dunk it. Unfortunately, that's not possible. Okay. I stopped trying that a while ago because I can't jump that high. Okay. There's a 0% chance. On the other end of the spectrum is something is 100% or 1 out of 1, which is certain. Okay. Certain things are certainties, right? That we're going to learn math today, or that we are going to, what's the probability of, if I was gonna flip a coin, what's the probability that I will get heads or tails? It's gonna happen, one or the other, right? So certainty. Okay. In the middle, we have 50%, 1/2, and we say this is as likely as not. Okay, as likely as not. It's as likely to happen as to not happen. So again, using our coin, okay, it is as likely that I will get heads as not get heads. It's as likely that I get heads as I get tails, right? Heads as not heads. So that's right in the middle. Okay. Now between between the middle and the either end, there's, we say, for example, if anything is greater than 50% chance, then we use the term likely. Okay. So this whole section is likely. Okay, it is likely to happen here to here. Now you can have different variations of likely. So for example, if something's like 90%, then you can say, oh, it's very likely. If something's like 55%, then you might say it's somewhat likely. Okay, but either way, that's the likely side. And on the other side then is the unlikely side. So things over here less than 50%, between 0 and 50, are unlikely. And again, you can vary it, use a different adjective and say, okay, it's very unlikely, somewhat unlikely. If something's like, 40% chance, it's not very likely. Yeah, okay, it's unlikely, slightly unlikely. Okay, you can kind of vary it how you want. All right, so let's talk about these simple events. Now, when we say event, okay, we're going to use this. We're going to say, what's the probability of an event happening? Now, when you say event, we are not talking about like a concert or a show. Those are events. Simple events or events in general, when we're talking about probability, are just the thing that's happening. So, for example, flipping a coin is an event. When I flip a coin, that's an event. Okay. When I roll 2 dice, that's an event. When I pull a number out of a hat, or a card out of a hat, that is an event. Okay, I know they don't seem very eventful, but those are the events we're talking about, the little mini experience. So the probability that an event will happen is equal to the number of what you want, of what you're looking for, divided by the total possible outcomes. Okay, it's the number of what you're looking for, what you want, divided by the number of total possible outcomes. And that total possible outcomes can get tricky sometimes. So we'll kind of go over some of those problems. If this doesn't quite make sense, don't worry. Don't as we kind of get there, you'll see. All right, so let's do an example. Letter A here. Let's say I'm going to roll a number cube. Okay, I'm gonna roll a number cube, a die, okay, single die, okay, and it's got numbers 1 through 6 on it. 6-sided die, 1 through 6. So what is the probability of rolling a 6? What's the probability that I will roll a 6? Okay. So we'll go over this one nice and slow. Some of you guys probably already know the answer, but we'll go over it nice and slow here. So I'm going to say, what's the probability of rolling a 6? Well, the first thing I want to do is I want to figure out how many 6s do I have on my number cube, right? I look around, I have 1, 2, 3, 4, 5, 6. There's only one, okay? So the first thing I want to look at is how many 6s are there? And there's only one. There is 1 6. Then I want to see what are the total amounts I have? What's the total amount of things I could get? Well, I could get a 1, I could get a 2, I could get a 3, I could get a 4, I could get a 5, or the 6 that I want. So that means there are 1, 2, 3, 4, 5, 6 total outcomes that could happen, right? That's what could happen. I could get any of the numbers 1 through 6. What I'm looking for is a 6, right? So let's say you're playing, Monopoly or some board game. You're like, I really need a 6. I really need a 6. Okay. What's the probability that you're going to get that number? It's 1 out of 6. Now, I also want you to do that in terms of percentage. So the first thing we're going to do is we're going to find decimal. So go ahead and do it in your calculator, 1 divided by 6. All right, you got that? 1 divided by 6. Just put in your calculator, 1 divided by 6. You're going to get 0.1666666, so on and so forth. Okay? We're going to move that and we're going to change it to change it to a percentage. So 0.66, remember, move the decimal 2 places. And I end up with 16.7%. Okay. So the probability of me rolling a 6 is 1/6 or 16.7%. So we would say that it's unlikely. Sorry, let me add that in here. It's only a 16% chance, almost 17% chance that I'm going to get a 6. Now, we know that it comes out. Sometimes we do get that 6 that we want, but that's why, like, when you're playing those board games, you're like, oh, I really need this number. Sometimes it comes, sometimes it doesn't. If you're really looking for just the 6, you're only giving yourself a 1 in 6 chance of getting what you want. 1 in 6 chance. Not super high. All right, let's try another one. Let's say you're going to roll that same number cube. What is the probability that you will roll a 2, 3, or 4? Not separately, just what's the probability of rolling either a 2, 3, or 4? So let's say that you and your brother are deciding who gets the last slice of pizza, and you say, you know what, let's roll a die. If I get it. If numbers 2, 3, 4 come out, you get it. If 1, 5, and 6 come out. So 2, 3, and 4. What's the probability of 2, 3, 4? 2, 3, or 4? This was a little bit tougher to think about, okay? All right, so again, there's 1, 2, there's 1, 3, and there's 1, 4. That makes a total of 3. There are 3 numbers that I could get. 2, 3, or 4. There's 3 numbers. You can see how this gets a little confusing as we're talking about numbers and how many the numbers are, but there are 2, 3, and 4. So, and what we said earlier in the last problem is there are 6 total. Okay, there's 6 total. So again, there's 3 options that we want, 2, 3, and 4, and there's 6 total, 1, 2, 3, 4, 5, 6. So the percentage chance or the fraction chance that I get 2, 3, or 4 when I roll is equal to 1/2. Or 50%. Again, do not try to do the probability of 2, the probability of 3, the probability of 4. You want to know the probability of getting any one of those, right? So let's say, again, you're playing a board game, and all you need, if you get a 2, 3, or 4, you win. So what's the probability that I get a 2, 3, or 4? 50%. It's pretty good. It's as likely to happen as not happen. Now, I would like you to reduce the fractions down if you can, but I know on the IXL that I'm assigning with this lesson, you actually do not have to. You don't have to simplify the fraction or reduce the fraction, just as is. All right, so that's simple probability, right? Simple probability. Again, you take what you want divided by the total amount of choices or options that we have. Okay. Let's move on to complementary events. Complementary events, okay? Not complimentary like they're going to tell you like, hey, that was a nice shirt, or hey, great hat there, Mr. Leon. Not that kind of compliments. Okay? Complementary events must add up to 100%. Or if you're doing fractions, they must add up to 1 whole. And it makes sense. So let's take the most basic example here. A coin. The probability that I will get heads is 50%. The probability that I will get not heads, or the probability I'll get tails, is 50%. If I add those together, I get 100%, right? 50 plus 50. So the probability of me getting either head or tails has to be 100%, right? Now you might be thinking, well, Mr. Young, what if the coin lands on its side, or what if I grab it in the air before it lands? No, don't do any of that. Just as if it lands on the ground. What's the probability that it's going to get heads? Okay. So think of it this way, right? What's the probability of rolling a 5 on a number cube? And what's the probability of rolling not a 5? So I want to know what is the probability of getting a 5, and I want to know the probability of getting not a 5. Okay, so let's think, right? How many 5s are there on a number cube? Well, there's only one. And how many total numbers are there on our number cube? Well, we've talked about this a few times now. There are 6. So there's a 1 in 6 chance that I'll roll a 5, and percentage-wise, that's the 16.7 that we had from before, right? There's a 16.7 chance that I will roll a 5 on my next roll. So then what's the probability that I won't get a 5? Let's say I really want a 5. If I get a 5, then I win the game, but I need just the 5. So what's the probability that I won't get what I want? Well, there are 5 numbers that are not 5, right? 1, 2, 3, 4, and 6. Out of a total of 6 total. 6 different numbers, rather. And notice 1, 6 plus 5, 6, if I add those up, they do equal 1. Do this in your calculator to get the percentage. Again, 5 divided by 6. And then move the decimal 2 places. And you should get something like 83.3%. You can also add these both up to make 100. Does that make sense? Again, complementary events have to add up together to make 100 because they cover everything that's possible. If I do all the possible outcomes, then I should have 100%. All right, last one's going to be kind of a set of problems here. Let's say I have a bag of Sour Patch Kids. I'm using that example because I do have a bag of Sour Patch Kids right in front of me. So let's say I like certain flavors. I want to know what the probability that I'll pick the flavor that I want, right? Without having to look inside, I'm just going to grab and see if I'll get the flavor that I want, or hopefully avoid the ones I don't want. Let's just say in our bag of Sour Patch Kids, let's just say to make the numbers easy, let's say we have 5 red ones, 8 green ones, and 7 yellows. What's the probability that I'll pick the color that I want? So green? Ooh, it's a yellow. So I want you to do these problems for me, okay? I want you to give me the fraction and the percentage. What's the probability that I'm going to get red? What's the probability that I will get not green? What's the probability that I'll get a blue one? And what's the probability that I will get not yellow? Please write down the fraction and the percentage for each. I'll give you a minute to do it. All right, the first thing that I would do here is I would probably find the total, right? We need the total for probability. So I want to know how many Sour Patch Kids are in my bag, right? If I got 5 red, 8 green, and 7 yellow, all I have to do is add those numbers up, right? 5 red plus 8 green plus 7 yellow. And I know that I have 20 total. Okay. So that's going to be really important to know because we remember the bottom number in our when we do our fractions is always going to be how many do we have in total. So let's start with the red. How many reds are there? Well, we see that there are 5 reds. And how many are there total? There are 20 total. So there you go. The chance that I have at getting a red one, right, is 5 over 20. Now, I want to simplify that, okay? Again, the IXL doesn't make you simplify it, but I think it's always good to try it. And I get 1 over 4, or 25%. Okay, let's do the next one. What's the probability that I'm going to get one that is not green? Well, the not green ones are the 5 red and the 7 yellow, so that's 12. There are 12 of them, out of 20 total. Now, we can reduce this fraction. We can divide it by, they're both even, so I know I can do 2. So let me check the next one, 4. Does 4 go into 12? Yes. Does 4 go into 20? Oh, yeah. Okay, so let's divide by 4 and 4 here. And I get 3 over 5. Now, again, how do I change that into a percentage? Do this in your calculator. Divide. In your calculator, do 3 divided by 5. You end up with 0.6. Remember, you move the decimal 2 places over, and you actually get 60%. Hey, not bad, okay? So if it's like, oh, I don't really like the green ones, what's the chance, is it likely that I'll pick one that's not green? Yeah, it's pretty likely. Okay, 60%. It's likely. Not huge, but not bad. All right, how about the blue one? Now, some of you guys are be like, Mr. Young, did you make a mistake? There aren't any blue in the bag. Exactly. So the chance that I'm going to get a blue is 0%. There's no chance that I could pull a blue out of here. Right? It's not like when you go to McDonald's or you go to some other fast food restaurant and you might get an extra like curly fry or something different. Like there's a little chance that you'll find an onion ring in your fries or something. No, there's no chance you'll get a blue. There's no blue here. None at all. All right, and if you didn't like the yellow one, you're saying, okay, what's the probability that I will get not a yellow one? That's the goal. I like all the other flavors except for yellow. Well, this is what we do. We know that there are 8 green and 5 red, so that's 13 total out of the 20 that we have in the bag overall. And then go ahead and again, in your calculator, 13 divided by 20, top divided by bottom, and then move the decimal to the right 2 places. All right. So that's kind of it. So this idea of probability is what are the chances that something will happen, right? And then you kind of adjust, and then we adjust our likelihood off of that. So if I'm talking about Sour Patch Kids, it's like, you know what? Someone said, here, take one, and you get to keep it. And it's like, ugh, I don't want a yellow though. 65% chance that I won't get it. Is that good enough? Will I still do it? Yes or no, right? That's the choice that you have to make. Now that you have the information of the probability, you kind of go from there. Okay. So again, that's for probability. You're just trying to figure out again how many of what you want over that total possible outcome. So you got to make sure you know what the total possible outcomes are, and then those things that you are looking for.